Hello and welcome back to Precalculus. On the menu for this lecture are systems of nonlinear equations, which are equations that have x squared and y squared, like equation of the circle, equation of the ellipse, equation of the hyperbola, and uh, and similar. Now, it doesn't have to be just square; it could be a cube and a fourth power, and so on. So. Um, In general, what we studied in algebra were systems of two linear equations, and then when you draw those lines, they intersect at the point xy, and you call that a solution. Now, when the lines are parallel, no solution. When the lines are on top of each other, infinitely many solutions. We also did 3 by 3 system, that's planes, that doesn't fit here. For the nonlinear systems, you can have y equal x squared. That's not linear, right? And the graph for that is the parabola. Now, we have seen this in chapter 2, we've seen it again in chapter 9, so we know really very well what parabola does and what it is. But then, on top of that, right, you can have another line, let's say y equals x plus 1. Now, that would be a linear line that goes like this. And as you can see, it creates these two solutions, right? So we are going to have, in this case, two solutions here when they intersect uh, like this. But they don't have to intersect like that. They can intersect in a single point. We actually call that the kiss in mathematics. There you go. We say they it will be like something is called a tangent line in Calc 1, and the definition would say, right, the tangent line kisses the function, meaning touches it at exactly one point, right? So that would be the solution. Or they could miss, and then there is no solution. So as soon as they have a contact, whether it's 1 point, 2 points, or more than 2 points, you will have that amount of solution. Every intersection of lines is the solution for the system. So now, if you go back and remember that x squared plus y squared um, equals to 16 is a circle with a radius 4. You could have a parabola, let's say open downwards, create 4 solutions with a circle. You can have that parabola intersect the circle, create 3 solutions. You can have it intersect for 2 solutions, or 1 solution. So there is nothing to memorize here. You will be solving these systems, and if you're able to graph, you would know how many solutions you are looking for. Just like for trig. If you remember for trig, right, its exam is coming up for equations. We said graph the left side, graph the right side, and see how many intersections you get on the interval that it's given to you. Well, in this case, pretty much the same thing, because I can have 2 circles, one inside the other, and they don't intersect at all. So no solution. But if I offset one circle, then we create the 2 solutions, or we create 1 solution. So geometrically, you can, right, if you're able to graph and you have proper paper for it and whatever else, right, you would be able to solve these problems to some extent. Obviously, when solutions have square root of 2 and square root of 3 in them, yeah, most likely no, but at least you know how many solutions you are expecting. What I found is the biggest pitfall of pre-calculus students taking these, working on these equations and solving them, is that you guys for some reason forgot from algebra, and it's happening for most of the students. You forget from algebra that when you are square rooting two sides of the equation, you have to put plus minus on one of the sides. So if you are solving an equation, and yes, I am writing this in red, I know, because such is life, x squared equals to 4, and you square root both sides, there is the plus minus in front of there, so your solution is x plus minus 2. See, s plus minus here would actually double the amount of solutions you get. So make sure that you have this plus minus every time when you square root both sides. It doesn't apply if you just have square root of 4. That's equal to 2. Nothing to do with plus minus. But if you had an equation x squared equals to 4 and you need to square root both sides, you have to put plus minus on the right hand side. So with this amount of review and this geometrical overview of nonlinear systems, it is time for us to take a look at some nonlinear systems. So it's just a couple of examples. They pretty much all, you can use elimination or you can use substitution, whatever works. Generally substitution, but I will also explain in which case you want elimination. So now, for this particular problem, you can do elimination or you can do substitution. It doesn't matter. Elimination is easier because all I need to do is to subtract two equations and y is dead immediately. So I will get x squared minus 2x equal to 0. That's my equation now, and we factor out x. We get x minus 2, from where x is 0 and x is 2. So this tells me that there are 2 points, right? And I need to find their y values, and I am done. Now, y value I can figure out from either of the equations. Now, obviously, the bottom equation is easier because we don't have a square. I mean, you could use the top. It's not a big deal to square a 0 and square 2, so whatever. When you go into the bottom equation, so for x equals 0, your y is 1 minus 2 times 0, which is 1. And that creates the point, the solution point of 0, 1. Then you go to the x equals to 2, and you do the same. Y is equal to 1 minus 2 times 2. Again, that's this equation when you move 2x to the right side. Get 1 minus 4 equals to negative 3. So the second solution is 2, negative 3. Now, these solutions should work in both equations. And you can mentally check 0 squared plus 1, 1 equals 1. That's good. And again, 0 plus 1, 1 is equal to 1. So the first solution works. Second solution is 2 squared is 4. 4 minus 3 is 1. 2 times 2 is 4, minus 3 is 1. So both solutions work in both equations. And that's it. We are done. Now, you might be interested in the graph for this, because graphical solutions should yield the same values. But for that, again, You need to have square paper. You need to maybe have a straight edge or something to draw these things properly. And then you can calculate the values for x squared to put the points so you can fit the best x squared possible, not just to draw any parabola. So the top equation would be y equals negative x squared plus 1. And the bottom equation would be y equals negative 2x plus 1. So when you write the equations in a form of a function so that you can graph them easier. Again, graphing is not necessary, but it's a good review for pretty much everything we did in this class, and also basic algebra to graph this linear line. Negative x squared, parabola opens downwards, and it's shifted 1 unit up from chapter 1, right? X equals to, when x is equal to 1, we have 0, so those will be here and here. When x is equal to 2, that's a negative 4, so it's a negative 3. So negative 3, and has to be symmetric with the positive 3. There we go. So I computed a couple of points so that I can draw somewhat decent parabola. And then we go positive 1, 2 units down, 1 unit over. So 2 units down, 1 unit over, 2 units down, 1 unit over. So that point, that point, that point, and draw the negative slope line. You can see intersection here, 0, 1. You can see intersection here, 2, negative 3, because that's 2 and that's negative 3. So it works, right? I mean, it has to work, obviously. It has to work, whether you do it graphically or not. Now, as I said, many times you're going to get square root of 2, square root of 3, and stuff like that. So you cannot really rely that you can solve every problem using these graphs. All right. Y squared minus x equals to 4, and x squared plus y squared equals to 4. This is 27. So this is another exercise in this way, sideways parabola and a circle. Now, I can expect 0, 1, 2, 3, or 4 solutions, depending which way they touch or not touch. Circle and the sideways parabola not touching, no solution. Circle and a parabola touching for one solution. Circle and a parabola touching for two solutions. Circle, come on, tablet, you can do it. Circle and a parabola touching for 3 solutions. Circle and a parabola touching for 4 solutions. Sideways parabola, right? So 5 possibilities. We know that, right, if we get 5 solutions or more, we know it's definitely wrong, because the most you can have is 4 solutions. So it's one of these cases. Now, if you graph everything carefully, the way we studied in chapter 9, plus the equation of the circle centered at the origin with the radius 2, you will know exactly how many solutions and maybe even what they are. But we can focus on calculations. Now, please note, both of these have y squared. Just simply subtract the equations. They both have, right? So elimination, and we're done. So y squared minus y squared will cancel, and you get minus x squared equal to 0. 4 minus 4 is 0. So on top, when you factor out minus x, you get 1 minus x equal to 0. So x equals 0, x equals 1. And when we are done with this calculation here, we can go back and figure out the y values. So when x is equal to 0, we can use y squared minus 0 equal to 4, y squared equals to 4, and here is the square root both sides with a plus and a minus, so y produces plus minus 2. That means that 0, 2 and 0, negative 2. So we got 2 points. With a single x equals 0, it gives us 2 points. Now x equals to 1, which is y squared minus 1 equals to 4. That's y squared equals to 5. And again, square root both sides, plus minus, and now you get root 5. So y equals plus minus square root of 5. That gives us 1 root 5 and 1 negative root 5. We have 4 solutions, which means that they intersect in this fashion here with 1, 2, 3, 4 solutions. So again, if you don't put a plus and minus, then you lose this solution, you lose this solution, so you lose half of your solutions if you don't put plus and minus. It's not there for decoration, right? Everything in mathematics works 100% of the time. The only question is, do we have enough knowledge and enough brain power to comprehend it? But there are no exceptions to the rule at any point ever in mathematics. No exceptions. One more problem. Let's see if we can find something interesting. How about a shifted circle at 40? X minus 1 squared plus y plus 1 squared equals to 5, and 2x minus y equals to 3. So x minus 1, y plus 1, and the 5, 2x minus y equals to 3. All right. It is time for substitution, because we can easily write y equals 2x minus 3. Right? Y goes to the right, 3 goes to the left, and we get y equals 2x minus 3. When you swap sides, y equals 2x minus 3. So that goes up there and replaces the y. Replaces the y, and then we have to square and do all of that stuff. So x minus 1 squared plus, open parenthesis, we have 2x minus 3. That's our y. Then we still have plus 1. Or that's another way. That's another place where your grades dies. You forget for some reason to just copy this plus 1. you go immediately close the parenthesis, put the square. That's another very common mistake. So copy that +1. So now we have to square these. That's going to be x squared minus 2x plus 1. That's our plus. Now we have 2x minus 2. So that's going to be 4x squared. And then because it's 2x minus 2, 2 times 2 is 4 times 2 is 8, so minus 8x. And then plus 4 at the end equals to 5. Now if you don't believe me that this is the way, just multiply it on the side. It's okay. So we have a 5x squared minus 10x, and then you have 1 plus 4 is 5, minus 5 is 0. So 1 plus 4 is 5, and then you subtract 5 from the right, it's a 0. Factor out 5x, get your x minus 2, x equals 0, x equals 2. You have your equation for y up there. So y equals to 2 times 0 minus 3, which gives you negative 3. And y equals 2 times 2 minus 3, which gives you 1. So the first point is 0, negative 3. And the second point is 2, 1. And we have 2 points of intersection for this shifted circle with a line. Now remember, with a line and circle and a line, they can have 2 intersections, they can have a single intersection, or they can have no intersection. But you can't have more than 2. So this was the maximum number of solutions. Trying to see if there are any other ones that are... Aha! Okay, one more. 34. This one has... Not 34, 32. 32. X squared plus 4y squared equals to 20. And xy equals to 4. So the top one is an ellipse, right? And you know that because we did that in 9.1. It's an ellipse. You divide by 20 everywhere. You get your x squared over 20 plus y squared over 5 equals to 1. So that would be an ellipse centered at 0. Now, we don't need this form, but I'm just going to quickly look at the graph of this because we can, right? It is x squared over 20 plus y squared over 5 equals to 1. So your a is root 20, which is 2 root 5, and then b is root 5. So this is one of the sideways parabolas where a is twice as big as, because this is 2 root 5, so a is 2 times larger than b. Now the other formula of xy equals to 4, when you flip that, you get y equals 4 over x, and that is 1 over x kind of graph. So we are expecting 4 solutions in the intersection of the ellipse and the hyperbola. Rational function. That's what I mean. Rational function. Now we already seen that technically the solution over here. You have your y is equal to 4 over x, and you just plug that in. So x squared plus 4 times 4 over x squared equals to 20. And when you square it, you get 16 over x squared, but 16 times 4 is 64. So 64 over x squared equals to 20. And you multiply entire equation by x squared to kill the denominator. So x to the 4th plus 64 is equal to 20x squared. And now when you put everything on the same side, you have quadratic. Well, it's a quadric, but you can reduce it to quadratic with the substitution. So the substitution over here, u equals x squared. Now this is intermediate algebra to solve this. U squared minus 20u plus 64 equal to 0. Factors of 64 that would add into a 20. What do we have? We have 1 and 64, 2 and 32, 3 doesn't work, 4 and 6, there we go, negative 4, negative 16. So u minus 4, u minus 16. But remember, u is x squared, right? So x squared equals to 4 and x squared equals to 16. I have to do that because you need plus minus 2 and this x is plus minus 4. So those are our x's. Now remember that the y was equal to 4 over x. Right? So y is 4 divided by plus minus 2 is plus minus 2. And over here y equals 4 divided by plus minus 4 is plus minus 1. So there you have it. It will be positive 2 and the positive 2 and the negative 2 and a negative 2. So 2, 2, negative 2, negative 2. And then we have 4 and 1 and negative 4 and negative 1. Do we have those on the graph? Where is my 2, 2? Probably this one. Where is my negative 2, negative 2? Probably that one. Where is my 4, 1? Probably this one. And where is my negative 4, negative 1? That one. Negative 4, negative 1. Negative 2, negative 2. Positive 2, positive 2. And 4, 1. There they are. All 4. And we see exactly where they are on the graph. Now this graph is terrible, obviously, because I didn't use proper scaling or anything, but just, looking at the coordinates, right? The y value for 2 has to be above 1, and the x value of 2 has to be to the left of 4. So this is the only way you can arrange these points to have the solution. And those would be your nonlinear systems. Why the nonlinear? Because you have squares. You can also have cubes. We had x times y. That's not linear, not allowed. Your linear form is y equal mx plus b, or ax plus by equals to c. At no point here you have x times y to be the part of it, or x squared or y squared or anything like that. Linear means this. Now, that was both of these forms were part of your linear systems in basic algebra. Now it's time for nonlinear systems, which means you are adding squares and all of those things in your calculations. Now, we have a good amount of examples here, variety with substitution, elimination. Square root, plus minus square root played a role a couple of times, which is good. And I did connect all of these to graphs that you should know, because we covered parabolas, ellipses, hyperbolas in this class, so you should be able to also anticipate how many solutions you are going to get. Questions, concerns about nonlinear systems? Nothing? Okay, well, happy when everything is so clear. I will see you all next week. Bye.